Is it just two of you? Is it just two of you?
House you could find.
Is there just two of you in there?
We have 3 rooms, so like it's
like if you've got a
250.
right.
If you guys remember last time,
I know.
hey, what did we do? What did we do on the last moment?
Prime numbers.
There we go. We talked about prime numbers. I love you.
So the day up.
Yeah, we did a prime number and composite number, and we talked about sieve of the hospitals, right? So we watched the video too. So we're gonna go over that a little bit more. We already know what prime numbers are, but here are the things that you can do with your students. So I'm gonna show you some things, okay? So I'm gonna use pictures to visualize prime numbers. I think that's very powerful for younger students because a lot of students are claiming that they are visual learners. I myself learn better when I have picture or some actual objects rather than just all the bunch of numbers and symbols there, right? So let's think about this situation. Old MacDonald had a farm here, okay? And old MacDonald is making a chicken coop for his best egg-laying hens. He has 7 hens, and he's thinking about how he can arrange the hens. He wants to arrange the hens in equal size groups. So can you think about how old MacDonald can arrange the hens? Any ideas? Yes. So here are beautiful chickens.
Those are so cute, actually.
Are they?
Sorry.
Yeah, I love them. I didn't draw it, by the way. You know that, right? So he arranged his 7 hens this way. Is there any other way he can arrange the hens? No, that's the only way, right? So recall, if you can have only one way of arranging it, because this is the same as the other way around. It's the same thing. So 7 times 1 is the only way. That's same as 1 times 7. So we consider that as 1, right? Okay. We see only one way of arranging the chickens. 7 chickens. We call that number as prime. If you have more than one way, you can see that it's not prime anymore. Okay? So here's the definition for prime. When there is only one possible way to divide a number into equal sized groups, that number is prime. In other words, there are only the factors of 1 and itself, like 1 and 7, right? So when we have only those 2 factors, we call that as a prime number. Okay? Okay, now, old MacDonald is also inventing a new, Old MacDonald is also inventing a new egg carton where he will store the eggs his hens lay. He wants each carton to hold 16 eggs. 16 eggs. Can you think about the egg carton that holds 16 eggs? How does the carton look like? Sloan, what do you think? How would you invent that egg carton?
2 by 8.
2 by 8, that's one way. That's same as 8 by 2. Any other? 4 by 4, that's another. Any other? Anna? You have little options, sorry. 1 and 16, right? Yeah, so we already have 3. Do we have more?
Can't you do 8 and 2?
8 and 2 is the same as 2 and 8?
Oh, well,
You need to pay attention.
I'm thinking like you could have 2 rows with 8, or you could have 8 rows with 2.
You can just rotate it. Well, I'm just saying, it's different. Yeah, thank you. So yeah, 1 row of 16 eggs. Another idea. That's same as 16 by 1. 2 by 8 or 8 by 10, 8 by 2. Lindsay and was it Rihanna? Okay, Rihanna. Rihanna said 4 by 4. And Sloan's idea, right? Lindsay, I got your idea here, right?
Yeah. That's what I was thinking earlier.
Yeah.
It's fine. I'm just gonna not say anything.
So 2 rows of 8 eggs or the other way around. You can think about this as 8 rows if you flip it over, right? With the same thing. So 8 by 2, or the last one, 4 by 4. they are putting the x, 16x differently. So if we have more than one way to arrange them, what do we call that number? Composite number. So like 16, it's a composite number. Okay, so we have an idea. Composite numbers have more than one way that they can be divided into equal groups. Okay? All right, so for upper grade, we can define the prime number and composite number a little bit more sophisticated. Like this. Any whole number with exactly two distinct whole number divisor, like 1 and itself, right? Then we call that a prime or prime number. Any whole number greater than 1 that has a whole number factor other than 1 and itself is a composite number. So composite number has more than two factors, right? 1 and itself, and there should be something else. Okay? Then we call that a composite number. Example 1, is 13 prime or composite? Show me your finger. So let's learn sign language. Does anybody know P? Uh-oh. I
For
don't
sign
know.
language, is that what you said?
I just learned about this summer. Like this.
P. Is
No.
that P? I
Something
think,
like this.
yeah, something like
Something
that.
like this.
Yeah.
Let me look it up.
Is that right? Look it up. I want to learn. My son's name is Philip, and I don't know how to spell sign language.
So it's K but to the side.
Oh, that's P?
Yeah. It said the letter P is signed like K.
Okay, so we learned the sign
It's close
language
to that.
P. C should be this one, right?
Yeah.
Okay, so if you think it's a composite, show me C. If you think it's a prime, show me P. 13, is it prime or composite? Ooh.
Down. It's
Oh,
down.
it's down, she said.
Yeah. Well, I am finding different ways to do this, but I knew it wasn't this because that felt weird.
Oh, yeah, this. I'm not doing it. This looks like P to me, but anyways, it
It
is
is
P.
it.
Okay.
Like,
So yes, it is a prime number because it has only two factors. One is 13. There we go. How about 32? Give me your sign. Whoa, I see. Okay, so it is a composite because 32 has more than two factors, right? More than 32, but it's also even number. So it divides by, it is divisible by 2, right? Okay, how about 1 then? What do you think? Because 1 is a tricky number,
oh,
isn't it? Yeah. Well, it's challenging, isn't it? 1.
Doesn't it start at 2?
I was gonna say I thought it was neither.
You guys are great. It is neither.
Yes.
Because,
Proud moment.
yeah, because think about it. What's the definition for prime number? How many factors? Two distinct factors, 1 and something else, right? But look at 1. 1 is only 1 times 1. There's only one factor. So it doesn't have two distinct factors, right? And it doesn't have more than two factors. It's less than 2, right? So it's a neither. Great job, guys. Proud of you. How about this one? Can you tell me whether this is prime or composite? Let's use our sign language again. Oh, I see. See right away. How did you know that so quickly? There we go. It's even number, which means it's divisible by 2, right? Without, regardless, thinking about any other factor, there could be any other factor too, but we know that it is divisible by 2, then 1 and 1564. Also, 2 is a factor. There could be more, so at least we know another one there, right? So yes, definitely it is divisible by 2, so 2 is also a factor and it is a composite. Right? How about this one? 2781. Oh, I see some of you already putting your hand up, showing C there. How did you know so quickly? Oh, how did you know? What's the difference? Aha! So we learned the divisibility test, right? We know how to find the divisibility test of 3. It is definitely not divisible by 2. So I'm gonna go to the next prime number 3. We know if we add all the digits and it's divisible by 3, that means this whole number is divisible by 3. 2 plus 7 plus 8 plus 1, 18, divisible by 3. there is at least 3 as a factor other than 1 in itself, right? So it is a complex number. How about this one? 1001, 1001.
Well, it's like here or here. I don't know. It looks so weird. But this one shows it like this. But they're all just different every time. So
I don't know. You can just go like this. Okay. So a lot of you think it's a prime number. So let's consider 1001. Let me bring that up here in my record. 1001. 1001. So let's think about if it's divisible by 2. Absolutely not, because it's not even number. How about divisibility of 3? 1 plus 1, 2 is not divisible by 3. How about divisibility of, we don't have to do 4, 8, right? Next step. Prime is 5. 5 does not divide because it doesn't end with
5 or 0.
5 or 0. What's the next one? 7? Does it divide 7? We didn't do 7 divisibility terms of 7. If we do divided by 7, 7 times 1 is 7, subtract and 40, 30, 28, and 21. Oh, what do you see? Okay, it is divisible by 7. So yeah, we didn't do the divisibility test for 7. So yeah. How about 11? We learned that. What do we do to test divisibility of 11?
Add every other number and it's
Yeah, we find the difference, right? So every other number, it's 1. Now you see that, right? And the other one, 1. So subtracted, 0. 0 is divisible by any number, right? It's divisible by 11 too. So yes. Right? So we already found at least 2 factor other than 1 and itself. So yes, it is a complex number. Okay? How about the last one? How about this one? It's complicated. So there could be 2 ways. One way, you can calculate the product of this and add it by 1. And then maybe you can do factorization or whatever. But it's kind of tedious, isn't it? We can think about, oh, there are 2 terms. So I have 3 times, 5 times, 7 times 11 as one term, and 1 is added to it. Think about what is in common, what is a common factor between these 2. Only 1 is common factor between this term and that term. Nothing else, right? Because 1 is only 1 times 1. No matter what that is, if we add that by 1, what do you think? It's gonna be even number?
Yeah, because
Because you're adding it.
when you multiply all those together, you're getting an odd number since they're all odd.
Wow, I love that thinking. So take a look. 3 times 5 times 7 times 11, that's
A big number.
a big number, but we know it's gonna be odd number, right? Because odd times odd is odd, odd times odd is always odd, right? So it is odd number. If we add it by 1, what happens? It turns into even number. An even number is always divisible by 2. So it is divisible by 2, whatever that is. So you don't even have to calculate the product and add it by 1, right? That's really great thinking. I'm so proud of you. Yeah, I am. Yeah. So yes, it is even number. So we can see that, oh, at least 2 is a factor other than 1 in itself. So yes, it is a composite number, right? Very, very good job. So how about this one? Prime factorization. Do you guys remember that you did this in high school?
Yes.
It's been a while. So you might have forgotten. So we can talk about prime factorization here. So let's talk about prime factorization. So in math, we need to know the definition of each word too, because like commutative property, we said, oh, you can commute the numbers, right? Associative property, you associate differently. The name is very related to what's going on there, right? So prime factorization, meaning we're gonna use only prime numbers, and what we're gonna do is we're gonna factor using only the prime number. For example, we have 260, okay? And we're gonna factor this. What is it divisible by? To me, I know it is divisible by 2, but I like to have times 10 because it's easier for me. Okay, it doesn't matter whichever number you start from, you can start from 2 as well. But I see 26 is not a prime number, and it's not a prime number. So you need to continue until you cannot do anymore. Using only the prime numbers. Okay, 26. What times what? It's an even number. 2 times 13. Oh, 2 is prime. How about 13? That's also prime. Then you are done. Circle all the prime numbers. Okay, so you don't have to talk, you don't have to think about that anymore. How about 10? 2 and 5 both are prime numbers. So we are done. We are done. Once you reach to all the prime numbers, you cannot do anymore. So we have 2 times 13 times 2 times 5. If I rearrange this in decreasing order or increasing order, let's go with increasing order. I have 2 times 2, which is 2 squared, right? I have 5 and I have 13. So I can rewrite this 260 with only prime factors. There is only one way to write a number with prime factors. Okay? There's one and only one way. Well, because this is the same, if we write that decreasing order or increasing order, we're going to have a certain way. Right? So these two are same thing, because we can use a commutative property there, and there's only one way. And that's really, really helpful. Okay, so we're gonna do prime factorization to do a lot of other things like finding LCM or GCF and so on and so on. Okay, so we already have done that. Oh, so we use a factor tree, but we can also do the stepwise there too. So I'm gonna show you how to do that here. Maybe some of you prefer to have that. I don't know. I like tree. Or maybe you like this more. So what you can do here is you can think about what is the prime number that goes in 260. I know 2 will, right? Then divided by 2, I have 130. Keep going on and on and on until you cannot do anymore. Another 2, 65, and I see it's divisible by 5, and I have 13 there. So all of these numbers, 2, 5, and 13, they are the factors, especially prime factors of 260. So that's another way, this different procedure, but basically the same concept. Okay, you see that? Awesome. Okay. Hey guys, close up your laptop. So we have one way to write 260 using prime factors. So we call it as a fundamental theorem of arithmetic. Can we read this out loud together? What does that say? What's fundamental theorem of arithmetic? Ready? Set? Read.
Each composite number can be written as a product of primes in one and only one way, except for the order of prime factors in the product.
Okay, so there's only one way to write the prime factors. Okay, here is the next theorem that we need to talk about. It says if D is a divisor of N, we know what that means, right? So that means N is divisible by D. Then N divided by D is also a divisor of N, which means, for example, if we have 6, so let's say my D is 2 and N is 6. I'm going with a really easy number. So we know that D divides 6. right? D divides 6. Then the quotient 6 over 2, which is 3, 3 also divides 6 as well. That's what it means, right? So if we know 20 is divisible by 2, then we know that 10 also divides 20, right? So those two are kind of compensating, right? They are factors for 20, so they have that relationship. Now we need to consider this one, divisor of 24. What are the divisors of 24? Well, I already had 24 with prime factorization, 2 cubed times 3. 2 cubed times 3. So we can consider all of that dividers here. Dividers of 2 cubed, you can consider what are the dividers of 2 cubed. What are the dividers of 3 to the 1's power? Then you can think about dividers of product of those two. So let's think about that. Okay. So we have 24 is 2 cubed. 24 is equal to 2 cubed times 3. And let's think about all the dividers of 2 cubed, and all the dividers of 3. And I want you to finally think about all the dividers of 2 cubed times 3. Okay? So, what are the divisors of 2 cubed? So, what divides 2 cubed? 1 does, right? We know that 1 and itself. We also know that it's divisible by 2. It's also divisible by 2 squared. Right? These two are complementing each other. 2 times 2 squared is 2 cubed. 1 times 2 cubed is 2 cubed. Right? We can rewrite this with base 2. That's same as 2 to the what power? 2 to the? This is 2 to the 1 power, 2 to the 0 power. So all of this, 2 cubed, 2 squared, 2, 1, 2 to the 1, and 2 to the 0 powers are all the divisors of 2 cubed. How about divisors of 3? Yeah, 1 and 3. 1 is 3 cubed, right? And 3. Now I want you to think about divisors of product of those two. You can have 1 and 3, 0, 1 times 1. Yeah, of course, that comes here. 2 to the 0 power, 3 to the 0 power, and 2 to the 0 power with 3, that could be another one, right? We can also have 2 to the 1's power with 3, 0, or with that and 3 to the 1's power. Same thing, for this one, you can have both, all of that. So if I list them all, you're gonna have these. Okay? So how many are there? 2, 4, 6, 8. Can we relate the number of divisors with the exponents here? We are adding to the 0's power. When we are counting, we count from 1, 2, 3, 4, right? 1, we count from 1. So we need to add 0 power as well. Not only 1, 2, 3, right? So we are actually adding 1 more to whatever the power is. So the actual number of the divisor is always 1 more than the power. Make sense? So for 2 to the 3rd power, how many divisors are there, Sloan? Always 1 more. So there should be not 3, but 4, because we need to count 2 to the 0's power as well. Okay? So 4 of them. For 3, that's 1 power, so there is always 1 more. So there are 2 divisors for 3. So when we are multiplying them together, we can just say, oh, there are 4 of them, and there are 2, so 4 times 2, total 8. So number of divisors, you can always add 1 more to the power in the prime factor, 1 more to the power, and you can multiply them together. Okay, so here comes the rule. Look at theorem 414. If P and Q are the different primes, N and M are the whole numbers, so we have prime factors of P to the nth power, Q to the nth power, then the total number of the divisor is one more than that and one more than that, and you need to find the product of that. Okay, so let's look at 24 one more time. 24. If we do prime factorization, we have 2 times 12, 2 is prime, 12 is not, so continue, 2 times 6, 6, 2 times 3. So we have 2q times 3, right? The number of total divisors of 24 can be just found by using this. 3 plus 1, I got this number from here, 3 plus 1 times, that's 1, 3 is 3 to the 1's power, 1 plus 1. You are just adding 1 more to the power. This is 4 times 2. There are 8 many divisors. Okay? So let me ask you another question. Let's just make up the number. How about 256? Let's change that. Yeah, let's do that. 256, I think it's okay. 256, 2 to the what power? Can you do the prime factorization of 256 and tell me what the factors are? Once you are done, I want you to think about 600. Catherine, what did you get?
I'm still working on it.
Working on it?
So I'm kind of confused actually. So do I just like divide it by 2 to get that started?
Yes, because it's even number, that's a good start.
Okay.
Two times 1 makes 256, guys.
128.
128. 128 is also divisible by 2. So 2 times what?
64.
64. 64 is
32.
yeah, 8 times 8, or you can say that's a 2 cube, and that's 2 cube. Yeah, so total, I have 2 to the what power? Yeah, 6, 7, 8. So 2 to the 8th power. So the total number of divisor for 256 is what? 8 plus 1. And there's nothing else. So it's going to be only that. 9. There are 9 different divisors. Okay? That includes like 1, 2, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, and 2 to the 8th. They are the only dividers. Okay? Does it make sense? Yes, Silon?
Where did you get the 1 again? The 8 plus 1?
2 to the 0th power. Well, 1 and itself are the dividers.
But like without writing the bottom part.
That one?
Yeah.
This one comes from, we are counting this. That's a really good question. So take a look. We are counting how many dividers there are. We have 1, 2, 3, 4, 5, 6, 7, 8 dividers. So we didn't count this one, right? This is 2 to the 0th power.
So you just always add the 1.
You always need to add 1 more to that because we are not counting. If we just count 1, 2, 3, 4, 5, 6, 7, 8, we are missing this one.
Okay.
Right? Okay, so that's why we are always adding 1 more. Okay, very good question. How about this one? 600. Can you guys help me? How would you factor this? With 100? 6 times 100? I like that. So both are not prime numbers yet, so 6 can be factored as 2 and 3. Both are prime. How about 100? 10 and 10, I like that. 10 and 10 are not, they are composite, they're not prime, so 12 by. Very good. And 12 by. We are done, right? Which is 2 to the what power? 1, 2, 3. 2 to the third. We have 3. And yeah, 5 squared. Very good. So 600 can be factored as 2 cubed, 3 times 5 squared. And let me ask you number of dividers. Number of dividers. How many dividers does 600 have? 3 plus 1 times, here's 1 hidden, 1 plus 1 times 2 plus 1. Why do we add 1? Because we didn't count the zeros column, right? We have 4 times.
I thought you added one expression, then you added one.
Make sense?
Yeah, I was just like adding up all the exponents first and then adding one afterwards, which we would get wrong.
Yes, yes, yes.
Got you.
Because we didn't count that to the zeros. Okay? So what is that? 24? There are 24 many dividers. If you have to list all 24, it's gonna be tedious procedure, right? Yeah, that's what we are doing. Any questions?
Can we do another one like that, please?
Absolutely. Absolutely.
Because I just got really confused.
Oh yeah, how about 720? Can you find number of? I love to see you guys enjoying this. Thank you. Find number of dividers of 720. First thing is what are you gonna do first? You're gonna find the prime factorization, right? While you are working on this problem, just quick announcement. I mean, it's not something new. I've been telling you guys this a lot of times. Please mark your calendar with a fixed schedule, like reading assignments. We have 2 reading assignments. Reading assignment 1 was due September 20. Reading assignment 2 is due October 20. It's not gonna change, okay? It's not gonna be changed. And also the final exam is not gonna be changed. You need to mark that in your calendar. You don't miss that assignment. And if you have missed that already, the first one, you need to talk to me. Yeah, but some other things like test, quiz, homework, they are subject to change, but I try to adhere. All right, are you guys done?
Almost.
Can I done?
We got 2, 4 times 290.
Tell me that.
Okay, I
Two to
did
the-
9 and 8. Well, are you like doing that?
Yeah, tell me
She
the
just
prime
means like
factorization.
Okay.
What do you have?
2 to the 4 times
2 to the 4th times
3 to the 2nd times 5.
times 5. Everybody, same thing? So I don't have to check it, right? Great job. Okay, so we know how to factor 720 using only the prime numbers. So we use the prime factorization, right? Now, number of dividers. How many dividers are there?
So there's 4 plus 1.
Yeah, 4 plus 1,
There's 2 plus 1
2 plus 1,
and 1 plus 1.
and 1 plus 1, right? We multiply them
So we
together.
get 5 times 3.
There we go, which is
30.
30. So there are
Okay,
30
got it.
many dividers. Can you give me some examples of those dividers?
Oh, I'm stupid.
I don't think you're stupid, don't worry. Guys, give me some examples of the dividers.
Oh.
Some examples of dividers.
So you mean like 1,
1 is a divider.
Two.
720 is a divider.
2, 1.
divisor, yeah. So you can put any numbers here, between 0 and 4, between 0 and 2, between 0 and 1. Then that's gonna be the example of the divisor. For example, it's not in order, but you can have 2 to the third and 3 times 5. This is one of the divisors, right? I can just make, put any number between 0 and 4. So 2 to the 4th, 3 to the 0, which is 1, and 5. This is also a divisor, and so on and so on. Let me ask you another question. Do you think 2 to the 5th times 3 times 5 will be the divisor of 720? What do you think? Yes or no? Is this a divisor of
No,
720?
because you don't have a 2 to the 5th.
Yeah, very good thinking. So it says you have 2 to the 5th power, which we don't even have. We have only 2 to the 4th power. So if you have exponents greater than these for each case, then it's not going to be the divisor. Does it make sense? Very good. Okay. So prime and composite is very good one that we can do with your students. Now I'm giving you big number. We have been practicing with a little bit smaller number, relatively smaller number than this. Now I want you to find the number of whole number divisors, the same thing, for each of these. How do we read this number? 1 million. Okay, 1 million. How about this? 210 to the 10th power. It should be a really big number, right? You don't want to find what 210 to the 10th power is. You can just use the exponent rule by finding 210 prime factors first, okay? So don't try to find the actual number for 210 to 10th power. It's going to be a really big number. We are looking for number of whole number divisors here. How many divisors each number has? Maybe 2 more seconds. Same answer? Kevin, you got it?
No.
You got it? You think? Maybe? Okay. Diana?
Yeah,
You
so
got
that's
it?
one.
You think you got
Yeah.
it? No?
What was the first one?
Okay,
Right.
you wanna see?
Yeah.
Okay.
I'm not saying it.
Okay, so 1 million. How can I use prime factorization for this one?
10 to the 6.
Ooh, I'm gonna start with that too. 10 to the 6th power. So 10 is not a prime number, so what can we do?
2 and 5 to this.
2 times
Yeah,
5.
10 is the same as 2 times 5, so it's the same as 2 times 5 to the 6th power. Now we are going back to chapter 3. So how can I rewrite this?
2 to the 6.
Yes, times 5 to the 6th. If you are there, you are done, right? Because we know number of whole number divisors is 6 plus 1 times 6 plus 1, right? So it's gonna be 7 times 7 or 49. There are 49 different divisors. Okay? So very good thinking. How many of you got this right? Good job. Similar thing here. So you can see what's inside. The base is 210. So you can change this to prime factors, right? So let's look at 210. 210 can be factored as what and what?
21 and 10.
Yeah, I'm gonna start from there too. Both are not primes, so let's go.
3 and 7.
3 and 7. 3 is prime, 7 is prime, 10 and 5. So nothing is in common, so we can put 2 times, 3 times, 5 times, 7, just ascending order. Okay, and to the 10th power, which is 2 to the 10, 3 to the 10, 5 to the 10, and 7 to the 10. So number of whole number dividers is 10 plus 1, 10 plus 1.
11 to the 4.
Yeah, so 10 plus 1 to the what power?
4.
4th power, or 11 to the 4th power.
Which is a very 14,641.
41, thank you.
You're
Okay.
welcome.
There are so many dividers for this one, right? So if you try to list that, oh my god, it will take like 5 days. Okay, so any question for that? I don't think you guys are good. So let's move on to this. We already talked about in the previous lesson yesterday, not yesterday, Monday, I showed you the method to find, where we can stop to find the prime numbers. So this is about that, and because we don't have much time for this, I will just skip this part, okay? Because we all know we need to stop at square root of that. So what I prepared here is really fun thing that you can consider. So if we are making a machine that can answer whether it is a prime or not. So something like this. So I'm gonna put a number in the box, in the machine, and the machine will say, oh yeah, it is prime, or no, it's not a prime, true or false. Is there any algorithm that I can use here? So the one way we're gonna think about is we're gonna find all the dividers. If there is more divisor than one in itself, it's gonna be composite, right? We can use that rule. So for example, if we are asking 49 is the prime number, we can think about 49 is divided by 2. We say no, it's not. 3. Where do we stop? If we keep going on and on and on, we can answer these and find whether 49 is a prime or not. But where do we start? You wanna go all the way to 48? No, you want. Where do you stop? You wanna come to 7. Why? Why do you stop at 7? Because think about 8. If 8 is, 7 is right in the middle, 7 times 7, right? So if we go something more than 7, and it's divisible by that number, it should be paired up with a number before 7. For example, think about 16. 1 times 16, they are pairing up. 2 times 8, they're pairing up. 4 is right in the middle. 4 squared, right? So 4 times 4, it's right in the middle. If you already checked with 2, you don't have to check with 8 because 2 and 8 are pairing up, right? So you don't even have to think about the number bigger than 4 squared, okay? For checking 16. So that's what I'm saying here. You can make a wall that where you stop checking. You can only check up to square root of that number. Okay, that's what is happening. So let's get this one. So you can use the base 10 frame on 100 table, but I'm not gonna do that because we don't have time. But for example, if I'm asking you to find whether this big number is a prime or not, it's gonna be tedious if we keep checking with divide by 2, divide by 3, divide by 4. Where would you stop? So numbers like this, it would be so much easier if you are just using your calculator and put square root of that number. How do we read that number? Can somebody read it for me?
2,979,215,073.
Oh, there we go. Can somebody else read it again? Regan. I mean you.
I'm gonna have to write it.
We need a commas, right?
Yeah.
Yeah, we have commas. I think so much easier. So here. It's a billion? 2 billion?
2,971,215,073.
There we go. Okay.
That doesn't mean you.
So,
It's
so
just like
if
a
we
fraction.
take the square root of 2,971,215,073, I get 54,508.85 okay? So that's what I get. So where do we stop? We can stop at this point, 54,508. But do we have to check all of the composite numbers there? No, you don't have to, because composite numbers means it has other factors than itself, right? So we can just check with only prime numbers, only prime. So for example, you can divide this by 2, you can divide this by 3, you can divide this by 5, 7, 11, up to this point, okay? That's what you need to do. We have only 1 minute left. So I want to finish this. So let's see what we do. So that's what all about it's saying. So thinking about 397, whether it's a composite or not, you can do square root of 397, and you get 19 point something something something. So you can check the divisibility test of 2, 3, 5, 7, 11, 13, 17, and 19, and you can stop there. You don't have to go even further, okay? Because that's the square root of that number. So when you rewrite that, square root of 397 is 19 point dot 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 dot. So you're gonna check the divisibility of all the prime numbers. There's 2 divided 397, there's 3 dot divide 5, 7, 11, 13, 17, and 19, and you can stop there. If any of these prime numbers divide 397, then this becomes opposite. If nothing from these prime numbers divides 397, it should be a prime number. Does it make sense? Okay. So I think we can stop here then, and I'm pretty sure you guys can complete the homework 4.3. Okay? So that homework is due.
Sorry, there's
That homework is due Friday, guys, okay?
bugs. Do you smell it?
Also, quiz
Nope.
3 is due on Friday, so you need to do both homework and quiz 3.
Here.
Alright, guys, have a good day.
I was wondering if you could spider this
Great.
What if I say no?